Hello to everyone, my name is Slava, I'm an aerospace engineer and today I will tell you about building, configuring and assembling my first FPV drone, which I call Bumblebee. Here you can see it's already assembled. I will tell you about components I use it, why did I use it, how did I assemble the drone, problems I faced during assembly and configuring, and finally I will tell you about some initial flight testing and feedback from this. So let's start. For my FPV drone, I decided to use a frame called SpeedyBee B35 Pro. This is a Cinewoop frame. It has a propeller guards. Because I'm a beginner, I found that it can be very useful because it saves me money on propellers. And also it protects a surrounding in case of some pilot error. For my flight controller and ESC, I decided to go with the newest SpeedyBee F405 V5 flight controller and associated OX32 ESC rated for 50 amp each channel. This is new product and I decided to go for kind of an experiment. However, I didn't even have many of choice because on the UK market, on the moment of building, there was much available options in stock. Then, for my camera and control system, I decided to go with a DJI solution in a form of DJI O4 Air Unit Pro on an air side and the use of DJI FPV Remote Controller 3 and Goggles N3 on a ground side. So in my system, effectively, the DJI unit playing a role of both video and control signal transmission, which for me is quite useful because it saves me some time and assembly and also it's quite compact. Then, for a power plant, or what I call a power plant, are the motors, propellers and the battery. I decided to go with SpeedyBee 2006 1950 kV motors with a 90mm 3-blade propellers and 6S 1480 mAh lithium polymer battery, which according to my calculations is about to give me 10 hours not 10 hours, but I wish it would be so, 10 minutes of hovering time. I had a choice of using either lower capacity battery, which would give me bigger aircraft flying dynamics, because a drone would simply weigh less, or go with a bigger battery, which would give me more flight time, but controllability and dynamics would be less. In terms of thrust reserve, here according to my calculations, the drone is expected to hover at 35% of throttle, while overall static thrust is 3.2 kilograms, I mean the maximum value, while the overall mass of drone is 600 grams, meaning that there is a plenty of power in reserve, which is good for quick climb and some aggressive and quick maneuver, or just a high-speed flying. Finally, I decided to equip my drone with a GPS unit. I use a SpeedyBee BZ251. GPS unit is essential for monitoring of a speed, monitoring of vehicle position with respect to ground point or me, and also for latest version of a Betaflight, it allows to use GPS hold flight modes. Last but not least is a buzzer. For buzzer, I decided to go with VFly Finder V2 buzzer. It's a buzzer equipped with its own battery, meaning that if there is something with a battery of a drone itself, then this buzzer remains sort of autonomous, meaning that I can more easily find it if a drone lands somewhere far away from me. So now, when we know the components I use for my drone, let's talk about assembling it all together. I begin an assembly of a drone from firstly soldering of main power distribution system, or what I mean is a soldering of each motor 3 wires to electronic speed controller. I didn't done soldering before, so before doing this project I have been firstly practiced a soldering on special soldering pads, practicing XT60 soldering, wire to pad soldering, thick wire soldering, and some very thin wire soldering. And actually it was really good decision, because when I started assembling real components, it really helped me. Unfortunately for me, the soldering of motors to ESC was quite well. You can see a photo. The next step after I soldered my motors was a soldering of my power distribution cable. Here you can see the capacitor located just on XT60. Typically on FPV drone you put a capacitor just for somewhere around ESC itself. However, this frame has a very small internal volume, so in order to fitting of big ESR capacitor is simply impossible. So I used a special distribution, like a capacitor mounting board for XT60, which helps to resolve this problem. The soldering of power lines was quite challenging, because the one who do soldering knows that soldering of thick wires is always quite difficult job to do, and it requires a lot of heating, and it requires some kind of patience. But finally, after some maybe around 1 hour of effort, I finally completed it. I had a bit of concern about quality of my minus black wire soldering to ESC, but actually when I checked its resistance, it showed me pretty much like around 0 value. So I considered this as okay. I didn't have any short circuits, which is also fine. And on this stage, a soldering of power distribution system have completed. The next stage of assembly was soldering of this small buzzer, maybe to around 28 gauge wires to flight controller. And also, what is specific for my flight controller is if you're going to use a S-bus protocol, and in case of DJI set, this is a protocol you use, you need to solder a little, you need to short circuit a little S-bus pads on your flight controller. So unlike a big power soldering, a big power line soldering, it required kind of opposite skills, like working on a very small scale. But nevertheless, it was successful. Then the next stage of assembly was wiring of a GPS. Here the most important was not to mistake plus and minus lines. Otherwise, it typically leads to a big damage of components. And then on this moment, the electrical assembly is somewhere around finished. So the next step was mounting a mechanical assembly. So what mechanical assembly were required, or what was the most difficult, is fitting a camera, because the camera uses very small screws, and you need to hit in a very confined space this screw hole in a camera. So it took me around 15 minutes just to do this one. Fit antennas here because I forgot to mention one interesting detail. This frame originally is not tailored for DJI 04 air unit, it's tailored for 03. So if you, as me, want to use 04, you need to buy a special DJI 04 transformation kit or adapter kit, which includes a special camera mount, specially fitted thin aluminum cap mount for the DJI 04. And also I used some of available TPU mounts for both antennas. The next final step in assembly was assembling all drone together. So how does it look is that you have this main plastic frame with a camera attached. Then you mount you push through your GPS module. However, this is easy. Then you have your entire second part with the motors, ESC and flight controller, and you have a wire. So you firstly take a wires, connect it all together, and then you need to kind of clamp it and ensure that any wire is not damaged in this process, and then screw everything. For mounting of my buzzer, I decided to exploit a provided action camera mount, meaning that I lose a chance to attach some action camera if I want to use buzzer, but nevertheless, for me it's not yet critical, and in future, if I will use action camera, this solution will be revised. So now drone seems to be assembled? Short answer is no. When I firstly connected my drone to a power, I had a couple of news. One is the good news is that everything is working, meaning that drone didn't explode, so meaning that I assembled or I soldered main wires properly. It was a good news. The bad news was that I didn't have a functioning camera. So what actually was the problem is that when I'm watching through my goggles, I could see my telemetry screen in Betaflight, like I could see a arming state, then other parameters, but there was simply image screen was simply black, and I was wondering like what is happening. Then I started investigating this problem, and what I found that in somehow, potentially during a crash or flying of my previous drone, I damaged this very delicate DJI-04 camera to video transmitter unit wire. And this was actually the reason why the camera didn't really work it. Fortunately, on the market I succeeded to find separately a cable, and then needed to make sort of surgical operation, trying to connect firstly one end of coaxial cable to camera, and then similar thing with a VTX. For this, what was really helpful is a video from official DJI channel. Thank you very much. And on this moment, the problem with the video image was resolved. The next problem I had was that I didn't have any feedback from my remote controller on a Betaflight receiver tab. So actually what's happened is that I did everything as I was supposed to do. I soldered S-Bus pad, I selected relevant serial RX port, and I enabled S-Bus baud fast and put the appropriate command in the Betaflight command line. This is called S-Bus baud fast on, but I didn't have any response, and I needed to disassemble my drone again. And actually what I found after around 2 days of investigations is that DJI-04 video transmission unit typically connects to flight controller through the 6-wire harness, plus, minus, TX-RX, ground for S-Bus, and S-Bus line itself. 5 out of 6 pins were working, but unfortunately for me, the pin responsible for S-Bus signal transmission was simply broken. Fortunately for me, DJI provides both options of electrical connection. These are SH connector and soldering pads, so I have resolved the problem by making soldered connections. And finally, after this, I have my remote controller working. You can see a short video. Then, on this moment, assembly of a drone is finished. Now let's talk generally about Betaflight configuring. So here, as I said, the main thing, if you're using the same parts as me, is you need to enable your so-called fast S-Bus option. You do it by enabling appropriate feature in DJI goggles, and then putting appropriate line in a Betaflight command line, and then you save and reboot. Other than that, setting of other aspects of drone is pretty much as usually. So I set some fail-safe. I did some settings on a flight modes. For example, what I did is one of the switches is a flight modes, another switches is arm disarm, another is camera, and finally another is fail-safe mode, then buzzer, and disable and activation of OSD. Shortly about OSD, for my first series of flight, I decided to maybe a little bit overcrowd my OSD, but nevertheless, I consider that it's maybe better to have a bit more information that, and later on refine what you actually use in flight and what is not. However, I preserve it an option that if I want to fly with a clean screen, I can disable OSD, and so actually when it happens, on my eyes, I can see only some DJI OSD, like overall voltage and overall transmission quality. And now let's talk about flying. For flying any new quadrotor, you typically need to fly in windless conditions, but if you're in UK, it might be some kind of problematic. And for flying of my drone for first time, I decided to fly on a backyard. I succeed to find or look for a forecast and find a relatively windless day. And I'm happy to share some of the footage. Enjoy! So now is the first outdoor flight. We will exercise standard hovering. And now let's go. So now, when you have seen some videos of first flying, I will quickly share my personal experience. First, what I would say is it's just mind-blowing to see your first drone, like which you assembled from scratch, flying without crashes. Okay, there was little one, but nothing bad happened. I was really happy that I were using this Cinewoop frame and anything get damaged. Another thing I found is that because previously I flew my previous drone in mainly GPS modes, while here I was flying in angle mode, what was truly difficult is a real controlling of a throttle, because I needed to make very little movements, primarily because I use a default throttle curve, which is just linear, so I needed every second make a little adjustment. Possibly in the future I will do a throttle expo profile, so that for hovering I have a bit more resolution, and then for quick flight and for higher values of throttle it's more responsive. But nevertheless, for first flight is okay. Then the good thing to tell is that I was kind of over conservative in terms of my hover throttle estimations. As you remember, I said that according to my calculations, drone is expected to hover at around 35%. However, what I found from logs and from own experience is that hovering like 30%, which is really good, meaning that there's even more reserve of a power for quick flight, some aggressive maneuvers and quick landing, and so on. And it's really positive. So you might now wanna ask, what then? Well, what you have seen is just a short, sanity check flight. My next step, but unfortunately due to the time of the year, it's unlikely to be very soon. I needed to make a global, more extensive flight testing where I fly in open air, like in a park or in a field, to see or explore my drone capabilities and controllability in a greater extent. I want to, for example, when we'll go on open air, I would like to see how well my drone is accelerating, decelerating, how does it respond to some change of directions, how much of active flight battery time is, or how endurant the drone during regular flying. Then I need to also practice my manual mode or acro mode flying, because so far I only flew in real life in angle mode. However, I would like to be capable to fly in acro mode, not just in a simulator. However, use of simulator was really useful for this project. Otherwise, I would crash this drone just quickly straight away. Thank you very much for watching the video. I'm happy if you would subscribe and follow my channel on YouTube and my Instagram channel, where I typically put different photos and some short stories. I would be happy if you would propose some topics to tell, or if you would actively ask any questions, and I would be happy to answer it. Possibly if you have some ideas about collaborations, I would be happy to discuss it. Thank you very much for watching. Have a good day.